Alright, starting with trig functions today. This is just the basics today, the easy stuff. I'll show you, make sure you've got a method of remembering this stuff. Sine, cosine, tangent. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay? So lots of ways that people used to remember that. When I was in Algebra 2, my Algebra 2 teacher said, where my mouse is here on the ratio, said, Oscar has another heap of apples. And I remember that ever since. A few years ago, a student said, oh heck, another hour of algebra. I thought that one was pretty funny. I like that.
Yeah,
some people write it out horizontally and use the SOHCAHTOA. And there's even a story that somebody made up about an Indian that goes along with the legend of SOHCAHTOA. So that works as well. Okay. Yeah, I don't do the one about the hippies on drugs. So I'll do that.
Tripping on algebra.
That's what Stu Dog taught her.
Yeah, well, Stu Dog, you know.
Stu Dog.
It's good. Alright, so however you're going to remember them, you need to write them down again right now. Get them there, and we're going to work some problems. Pretty easy stuff today. Most of these problems will involve the Pythagorean theorem because you're not going to know every side in the beginning most of the time. Alright, everybody ready? Ready to work one? I'll throw a piece of graph paper on this one. Alright, what we know right here says the terminal side of an angle theta in standard position passes through the point 12,5. So let me read you all that stuff I said again. The terminal side of an angle theta in standard position passes through the point 12,5. Find the values of the 6 trigonometric functions. Now, I only wrote 3 on the board a second ago. The other 3 are the reciprocals of all those, and I'll give you their names here in just a second. What that's talking about when it said terminal side of standard position, your initial side, we're always going to start at the origin, obviously. Your initial side will always be a right here. Okay, then from that, if we go find that point 12,5, let's see here, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3, 4, 5. There's that point, and then if I'm looking at a ray that goes through that point, that forms your right angle. Good morning, Mr. White. I appreciate it. Thank you much. Okay, so we've got that ray from the point they gave us, and now you see where your right triangle is. I just dropped that height there to make my right triangle. And now angle theta is always going to be the one at the origin. Okay, so there's my angle theta. And y'all remember from Algebra 2 and geometry that theta is just a symbol for trig. In algebra, lots of times it's x. In trig, they use theta, which is like the 0 with the curly Q in it. So if you see the theta, it's the same as x. Alright, so what I need to know now are what are the dimensions of this triangle that I drew. How long is this base from the origin to that height? 12. And we know it's how tall? So what I'm missing is the hypotenuse. So we've got 5 squared plus 12 squared equals c squared. The hypotenuse is always seen in your Pythagorean theorem. This is easy stuff.
I need the following students in the high school office: Ethan Wetzel, Landon Morrow, Shane Small, Sean Small, and Christian Creed. Thank you.
So that's 25, 144, 169. That's a perfect square, so my C is 13. Alright, so now looking from angle theta, I do this initially in Algebra 2, and I'll do it here with you. I'm going to label all this stuff. 13 is my hypotenuse. Okay, it's always the longest, and it's easy to tell. 13 is longer than 12 and 5. If you're ever supposed to just tell by looking and you can't, remember the hypotenuse is the one that's opposite the 90-degree angle. Okay, so there's my hypotenuse. Opposite is the side that does not touch angle theta. Angle theta is made by that ray and that ray. So 5 is the one not touching it. So there's your opposite. And then the one that does touch angle theta on that ray is your adjacent. Okay? So I'm going to erase my Pythagorean theorem work there and we'll start filling these in. Sine, cosine, tangent are the first three. And remember this problem asks for 6. So we'll have to add on to this for a second. Sine is opposite over hypotenuse. Yep. Just leave it that way. Cosine is adjacent over hypotenuse. I'm just leaving these in a fraction, and if they'll reduce, I will, but so far nothing will reduce. Tangent is opposite over adjacent. That's why I like to label them all over here, so there's no guesswork in it. I'm just good to go. All right, now the question said give the 6 trigonometric functions. That's only 3. These dudes have reciprocal trig identities. Sine is the reciprocal of cosecant. It's abbreviated CSC. Sine and cosecant. So all you do is flip sine and you've got cosecant. So the cosecant here would be 13 over 5. C-O-S-E-C-A-N-T. I made a dumb T. Okay, now cosine is the reciprocal of secant. It's abbreviated SEC. So we just flip cosine. And then cotangent, COT, is the reciprocal of tangent. So we just flip it. Good. Pretty basic. The only math that we had to do there was the Pythagorean theorem. Rest of it, we just put the O's and the H's and the A's in the right spots. Only time this becomes a little bit more intensive is when a radical is involved, because you can't leave a radical on bottom, and we'll have to get rid of that. It's called rationalizing the denominator. Whew. All right. Let's do another one. Let's do another one. Everybody got what you need on that one? Alright, this time it says the terminal side of an angle theta in standard position passes through the point 8, -6. Find the values of the 6 trigonometric functions. So 8, -6 means it's going to be down here in quadrant 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Okay, so we got that point. Which means the ray would be there. So you can draw your triangle by dropping that height. There's your 90-degree angle. Okay, what is this distance where my mouse is? How far did we go over there? 8. How far is this? 6. Now I went down 6. As far as distance is concerned, Austin's right, it's just a 6. But I'm going to have some negatives to deal with in my answers. So I need to keep in mind that that's a -6 for that purpose. But it doesn't matter in the Pythagorean theorem, it's just a distance of 6. Okay, so we're missing our hypotenuse. So I've got 6 squared plus 8 squared equals C squared.
Coach Wright?
Yes.
Can I get Kelsey Burks at your convenience, please?
Yes.
Thank you.
So that gets me 100. So I know that my C is 10. So I'm looking there at a C of 10 on that. Okay? Now that's actually a common Pythagorean triple. Y'all remember from geometry, there are lots of common ones, 3, 4, 5. This is just that doubled, 6, 8, 10. That's a common one. So you could have gotten a 10 without doing the Pythagorean theorem on that. Okay, that's a hint to you that these ratios are going to reduce this time. Alright, so let's label hypotenuse is 10, opposite is the -6, and adjacent is the 8. So sine is opposite over hypotenuse, which reduces to -3/5.
Will it always tell you what your theta is, or do you just have to know?
Theta, when you're doing it this way with this point, theta will always be the one at the origin.
Okay.
Cosine adjacent over hypotenuse, which is 4/5. Tangent opposite over adjacent, which is -3/4. Okay, we're going to flip those for our reciprocal ones now. What was the reciprocal of sine called? Secant, very good. So it'll be -5/3. What was the reciprocal of cosine? Secant, very good. So that'll be 5/4. And then cotangent, very good. Will be -4/3. Now, you'll remember when we did this in Algebra 2, and I don't know if you did in geometry or not, but when we looked in Algebra 2 at the unit circle, we were able to look at each of these quadrants and figure out your signs in there. So if I had forgotten to put that 6 down, that negative down here on the 6, I could have went and said, well, in quadrant 4, I know sine has to be negative, and I could have added the signs that way, but it doesn't matter. Do y'all? Never mind. I'm not going to go that deep today. Shelby said no. Louise said no.
Yeah. Come on, picture. I was the one who was
Okay. Let's look at Alright, look at this ugly thing I gave you. -√2, -√2. Alright, so first off, square root of 2 is an irrational number. It's going to be a decimal that goes on forever. But I know that's going to be in quadrant 3. So I know my ray is going to come down here because negative means I go left and down, right? Now what times itself equals 2? It's like 1 point something. So not going to be very big. Okay, so I'm not going to stress right now. And if this bothers you, I'm sorry. I'm just going to give you a ray in the right quadrant. Now, how am I going to know how long those sides are? Based off this point, so check this out. If I draw my height there, I went left, -√2, and I went down, -√2, right? So I didn't have to panic over, I don't know how far square root of 2 is, it doesn't matter. If I counted all my squares up there, it'd be so small I wouldn't be able to see the triangle. So we just kind of made that work there. But we do need to find the hypotenuse. Okay? So I'm going to have -√2 squared plus -√2 squared equals c squared. Now, first off, when you square that negative, it becomes a positive, and when you square a square root, it just cancels out. So that's just 2. So I've got that on both cases. 2 plus 2 equals c squared. 2 plus 2 is 4. So my c is 2. So 45, 90 shortcut there. Any of y'all Trig people remember that? Alright, so here's your angle theta that Bailey talked about. So 2 is my hypotenuse. So these dudes are my opposites and my adjacents. I wrote that on the wrong spot. It doesn't matter because they're the same, but I need to label them correct. Keep going if I do adjacent and opposite. Alright, so you're going to see here, some of these are going to, the dilemma is you're going to have a radical on bottom. That's what I talked to you about a second ago. We have to rationalize the denominator when that happens. Sine will be okay. It's opposite over hypotenuse. And that's okay because the radical's on top. It can be there, so that's good. Cosine is the same. It's adjacent over hypotenuse. Tangent is opposite over adjacent. Now this one, a lot of people will start to panic on and start trying to rationalize the denominator, and I could, but that's a common sense one there.
Isn't it just one?
That's a kid, Bailey. It's the same thing on top and bottom, which means that's positive 1, because a negative divided by a negative. Good job. Alright, now when we start taking the reciprocals here, this is where you're going to get the radical on bottom, and we got to do a little bit of work. Reciprocal of sine, cosecant, would flip that to 2 negative over square root of 2, and it's negative. Tell you what, I'm going to write
Would it be
over.
negative 2?
The negative just has to go somewhere. It doesn't matter if it's where, as long as you get it up there one time. Alright, so if I've got, I'm going to write this over here in different colors so we can see it. If I've got this, and I need to get rid of that radical on bottom, I'm going to apply the top and the bottom by the square root of 2. So that gets me negative 2 square roots of 2 over square root of 2 times square root of 2, square root of 4, which is 2. So that is your cosecant. Remember that? Can't leave a radical on bottom stuff. Now, good news for you is cosine was the same as sine. So that means secant's reciprocal is going to be the same, right? So you don't have to do that again if you notice the common sense there. All right, Louise, what's the reciprocal of 1? What's my cotangent? Very good. You made me nervous for a minute.
I got confused.
I noticed. All right, so there are, it's an interesting circle, all the answers.
That's a good circle.
I thought so. Alright, what do y'all think on this? You need more? You good? Questions, comments? When would I have an undefined on one of my functions? What would have to be involved to have an undefined on one of my functions?
0.
0 on the bottom. Very good, Mr. Gwatney. So that is possible to have 0 for an answer if the 0's on top, or undefined if the 0's on bottom. That happens if you think of this in terms of your trig stuff. That happens like if you're at a 90-degree angle, right? Because that would have went over 0 and up. Or if you're on the y-axis, because that would have went up or down 0, the x-axis. So it's, you get those zeros there. Do we need to do one of those? Okay. I hope so. But you know, Louise.
Are you saying I'm not? I don't have any common sense?
Alright, so next week we'll get into just some more, a little, you know, we don't go super deep in trig in here, but we do go a little bit deeper. We'll get into Pythagorean identities and quotient identities and that kind of stuff next week.
I don't know when it's coming. Hey, about everything.
Isn't this similar?